Hello and welcome back to yet another episode. Myself, Fazira Razak Hamza, Assistant Professor in PG Department of Computer Science, and I am here to present on the course Principles of Software Engineering. In the last episode, we were discussing about Unit 2 of the course, which was Requirements Engineering, and we've discussed about the steps in requirements engineering and how to establish a groundwork or a base. Today, I'm going to discuss on eliciting requirements. Let's start. The requirements elicitation, also called requirements gathering, combines elements of problem solving, elaboration, negotiation, and specification. So, in order to encourage a collaborative, team-oriented approach to requirements gathering, stakeholders work together to identify the problem, propose elements of the solution, negotiate different approaches, and specify a preliminary set of solution requirements. So, the steps to be followed for eliciting requirements are: first step is collaborative requirements gathering. See, many different approaches to collaborative requirements gathering have been proposed. So each approach make use of different scenarios, but all apply some variation on the basic guidelines. Let's see what the guidelines are. All the approaches follow the basic guidelines. Meetings are conducted. So first they do is meetings are conducted and attended by both software engineers and other stakeholders. They not only conduct a meeting, but they are attended by both software engineers and other stakeholders. Then rules for preparation and participation are established. Okay. Then an agenda is suggested that is formal enough to cover all important points, but informal enough to encourage the free flow of ideas. A facilitator controls the meeting. It can be a customer, a developer, or an outsider. Then a definition mechanism is used. Let's see what a definition mechanism is. It can be worksheets, flip charts, or wall stickers, or an electronic bulletin board, or chat room, or virtual room. So here the goal is to identify the problem, propose elements of the solution, negotiate different approaches, and specify a preliminary set of solution requirements in an atmosphere that is conducive to the accomplishment of the goal. So let's see a brief scenario on how it works. Okay. So during inception, basic questions and answers establish the scope of the problem and the overall perception of a solution. Am I right? Because inception is establishing the scope of the problem. Out of this initial meetings, the developer and customer write a 1 or 2 page product request. A meeting place, time, and date are selected. A facilitator is chosen and attendees from the software team and other stakeholder organization are invited to participate. The product request is distributed to all attendees before the meeting date. So this is how a simple scenario works during inception or during eliciting requirements. So we finished with the step collaborative requirements gathering and eliciting requirements. Now the second step is quality function deployment, that is QFD. So QFD is a quality management technique that translates the needs of the customer into technical requirements for software. So QFD concentrates on maximizing customer satisfaction from the software engineering process. So, to accomplish this, QFD emphasizes an understanding of what is valuable to the customer and then deploys these values throughout the engineering process. So, here QFD identifies three types of requirements. Let's see what are the three types. First type of requirement is normal requirements. The objectives and goals that are stated for a product or system during meetings with the customer. This is what normal requirements look like. So if these requirements are present, the customer is satisfied. So for example, we can say that graphical displays, specific system functions, defined levels of performance, these are all come under normal requirements. Now the second one, that is expected requirements. These requirements are implicit to the product or system or may be so fundamental that the customer does not explicitly state them. So we can say that the expected requirements are those which are fundamental for the development of the software. So actually their absence will cause dissatisfaction for the software. We can say example as ease of human or machine interaction, overall operational correctness, reliability, ease of software installation. All these requirements come under expected. Now we have the third category, that is exciting requirements. So as the name suggests, these requirements go beyond the customer's expectation and prove to be very satisfying when present. For example, we can say a software for a new mobile comes with standard features, right? What are the standard features? Standard features may be touch screen or something else which supports the software of the mobile. So that is exciting requirements that delight every user of the product. So QFD uses customer interviews and observation, surveys and examination of historical data as raw data for the requirements gathering activity. These data are then translated into a table of requirements called the customer voice table, which is reviewed with the customer and other stakeholders. A variety of diagrams, matrices, and evaluation methods are then used to extract expected requirements. So this is QFD, quality function deployment, with three types of requirements. Our next step is usage scenarios. Okay, let's see what usage scenario can do with eliciting requirements. See, as requirements are gathered, an overall vision of system functions and features begins to materialize. So it is difficult to move into more technical software engineering activities until you understand how these functions and features will be used by different classes of end users. So for this purpose, developers and users can create a set of scenarios that identify a thread of usage for the system to be constructed. The scenarios, often called use cases, provide a description of how the system will be used. So for providing a description on how the system can be used, we develop a scenario which is known as use case. Okay. Either a use case or we say it as UML, Unified Modeling Language, that we are developing a model of the same. Our next step is elicitation work products. What are the work products that are represented or that are released during elicitation? The work products produced as a consequence of requirement elicitation will vary depending on the size of the system or product to be built. So, for most systems, the work products include a statement of need and feasibility, a bounded statement of scope for the system or product, then a list of customers, users, and other stakeholders who participated in requirements elicitation, a description of the system's technical environment. So all these work products is reviewed by all people who have participated in requirements elicitation. So now a list of requirements preferably organized by function and the domain constraint that apply to each of these work products. Then a set of usage scenarios that provide insight into the use of system or product under different operating conditions. Then we have any prototypes developed to better define requirements. So all these work products is reviewed by all people who have participated in requirements elicitation. So these are the work products which have been released during the process of elicitation. Then we'll see how we can develop a use case, developing use case scenarios. It describes the system's behavior under various conditions as the system responds to a request from one of its stakeholders. So, a use case tells a stylized story about how an end user interacts with the system under a specific set of circumstances. The story may be narrative text, or an outline of tasks or interactions, or a template based description, or a diagrammatic representation. So, a use case depicts the software or system from the end user's point of view. The first step in writing a use case is to define the set of actors that will be involved in the story. So we need some actors, which is the first step to be done here. So actors are the different people or devices that use the system or product within the context of the function and behavior that is to be described. Actors represent the roles that people or devices play as the system operators. An actor is anything that communicates with the system or product that is external to the system itself. So, an actor and an end user are not the same. A user can play a number of different roles when using a system, whereas an actor represents a class of external entities that play only one role in the context of the use case. Okay, so you have understood the difference between actor and an end user. Not all actors are identified during the first iteration. Primary actors are identified during the first iteration and secondary actors are identified when the system is learned further. So primary actors interact to achieve required system function and derive the intended benefit from the system. They work directly and frequently with the system. Okay, these are the duties of the primary actors. Now let's see what secondary actors do. Secondary actors support the system so that primary actors can do their work. So once actors have been identified, use cases can be developed. For example, I'm saying as an example, we are bringing a safe home function to market in order to provide home security. So we are creating a control panel which secures a home. Okay, the home security function would protect against and recognize a variety of undesirable situations such as illegal entry, fire, carbon monoxide levels, and other categories. So here, a wireless sensor is used to detect each situation. It can be programmed by the homeowner and will automatically telephone a monitoring agency when a situation is detected. So let's see who are the actors in the home security system. So here we define 4 actors: homeowner, which is a user, then setup manager, then sensors, devices attached to the system. Sensors may be likely the same person as homeowner but playing a different role, and the monitoring and response subsystem, that is the central station that monitors the safe home security function. Okay. So the homeowner actor interacts with the home security function in a number of different ways using either the alarm control panel or a PC. It enters a password to allow all other interactions, inquires about the status of a security zone, inquires about the status of a sensor, presses the panic button in an emergency, and activates or deactivates the security system. So here we are only considering the homeowner actor for the purpose of explaining use cases. Let's see what a homeowner does. This is the figure of a safe home security function, considering the situation in which the homeowner uses the control panel. So first thing is that the homeowner observes the safe home control panel to determine if the system is ready for input. If the system is not ready, a not ready message is displayed on the LCD. This is an LCD, so a not ready message will be displayed here. See, we can see not ready, bypass, instant, stay away. So a not ready message will be initiated on the LCD display, and the homeowner must physically close windows or doors so that not ready message disappears. Okay, so not ready message comes because we have not closed the doors or windows that the homeowner should do physically. Okay, so not ready message implies that a sensor is open, which means that a door or window is open. So second thing, the homeowner uses the keypad to key in a 4-digit password. This is a keypad which have so many numbers which indicates some code on the numbers. The password is compared with the valid password stored in the system. If the password is incorrect, the control panel will beep once and resets itself for additional input. Now, if the password is correct, the control panel awaits further action. The third one the homeowner does is that the homeowner selects the keys in stay or away, okay, to activate the system. Stay activates only perimeter sensors, that is the house in which it works, that is the perimeter sensors. Away activates all sensors. Away means there is nobody at the home, so it activates all the sensors. Now, the fourth activity done by the homeowner is when activation occurs, a red alarm light can be observed by the homeowner, either in the PC or in the mobile which they have installed or communicating with the control panel. Okay. Now, the basic use case presents a high-level story that describes the interaction between the actor and the system. So this first figure we show the simple low-level story. Now there is a high-level story for a use case also. This is how a high-level story will be like. There will be a homeowner, system administrator, then different kind of sensors. Okay. The sensors will be response to alarm event, encounters an error condition, reconfigures sensors, and related system features. So this is a UML use case diagram for safe home security function. So this is how a high-level use case looks like. So use cases for other homeowner interactions would be developed in the same manner itself. Okay. So hope you understood what is a use case scenario. Thank you. Thank you so much.